Yeah, thanks everyone for coming despite this early morning. It's a pleasure to be here. Before I start, I'll just get some water in this because I just had my breakfast and I'm thirsty. It's very hard to find water in this building. I don't know if you guys observe that. Let's see if this is working. Excuse me. Is it working? Oh, wow. Can I try? I can't do it here, I guess. No, okay. No. Okay, yeah. So the talk is about document grounded, how grounded is document grounded conversational AI. So before that, I want to quickly talk about grounding. And grounding is one of the key things that we do every day. And that's if we can't do it, we can't communicate. So it's a way to connect language to a shared space or shared knowledge source that we all can verify. So if you take this example, a corgi inside a house made of sushi, it would be this picture. Like, so I was able to communicate this idea, and probably like you and I shared this particular picture. This is generated by ImageGen, by the way. If you see examples of grounding in the literature, we see a lot of language and vision. So if we say giraffe facing away, the tallest giraffe, you can pinpoint what it is, and you see the exact giraffe. And in the NLP world, like we see also grounding in semantic parsing a lot. So if you take this statement, Leonardo DiCaprio starred as Jack in Titanic, which was directed by James Cameron, this can be grounded as a code. So in this particular case, as a free-based query, and I can validate whether this is true or not, and you get true. But we want much more freely conversational system, so something like you can converse much more freely. So if you see recent progress, we exactly don't know how grounded these conversational models based on large language models are. Now we know we have GPT-3, Palm, we are extremely successful, but it's not very well defined how grounded these are. And one of the things is that the knowledge is stored in millions of parameters, it's billions actually. So it's really hard to validate what these are. And if you actually see the responses, so if you take this health category, can coughing effectively stop a heart attack? GPT-3 could say coughing can help stop a heart attack. We really can't validate whether this is true or false. At this point, we might be trusting GPT-3, and the same also with what happens if you crack your knuckles a lot. So how can we build a much more grounded conversational systems? And this is where some of the linguistic literature can help us. Excuse me. So if you see theories like natural logic, they enable you to verify whether something is true or false with respect to other facts. So if you take this particular and no carnivores eat animals, in order to verify that statement, natural logic would say, hey, go and find some other statement that can validate this or not. So it could be the cat ate a mouse, and when you see that, it automatically contradicts what you saw. So this is one way to validate your statement. So the biggest challenge for us, I think, is to first evaluate how grounded our conversational models are. And even with retrieval, we observe that they have a lot of hallucinated information, and it's not clear why these models hallucinate. They produce unverifiable information. So we will look into that. That would be part one. And we will also be looking into how can we build much more grounded models, like how can we increase the faithfulness. I will be talking about two specific solutions. And the third one, stop going. Yeah, okay. So the third one is, we would also point out, so we are relying a lot on retrieval, But retrieval itself is not so easy in conversational settings. So we will also be looking at some other challenging things in conversational retrieval. Okay, going to part one. So this is a paper that we have at ACL2022 to be presented. So we investigated where the hallucinations are coming from, why these models, even though they're retrieval-based models, is it because of the data sets that they are built on, or is it because of the models that we have this hallucination phenomenon? So we took the very popular data sets for conversation, document-grounded conversational models. So Wizard of Wikipedia, CME-doc, topical chart, very big data sets. And the setup is as follows. If you have a seeker, have you ever had a broken heart? So this is a person interacting with the system. And the first step the wizard has to do is retrieve a relevant piece of knowledge. So that would be something like a broken heart is a term, and you see it's an emotional, intense, everything. And now it's wizard's turn to reply based on this knowledge snippet. And here the wizard says, yes, I did last year when I broke up with my girlfriend. It was terrible. It's a very amusing response. But do we really want wizards to do this? Like, do we want bots to do this? We want them to be much more grounded. And here, if you see, it's not making use of the information that is presented. It's just inventing, or the wizard, the person, the actual person decided I would make it much more interesting and invent this response. Okay, so we asked linguists to identify based on natural logic, like entailment and different classes, to identify whether something is hallucinated or not. And if you look into existing data, so this is Wizard of Wikipedia, which I'm guessing most people in this room probably might have used one point or the, and 62% of the responses created by wizards are actually hallucinated. You cannot just rely on the knowledge to generate a response. So that response is coming from one speaker's knowledge. We will look into what these responses are. And yeah, and even when they're if they try to stick to the knowledge, what they end up producing is uncooperative responses, which would not fit in that context. They would still be faithful or grounded, but they're not suitable in that context. And if you take other data, CMU-doc, it's the same story. There are 67% hallucinated responses in the data set. And the topical chart, it's the same. So what are the hallucination strategies that wizards use in these data sets? I will talk about three strategies that they mainly use, but mainly two actually. So if you look at edification, so this is being used close to 45% of the times. So if you take here, the seeker says, I haven't seen latest Harry Potter movies, and the wizard says Harry Potter received many awards. And the knowledge the wizard is using here is Harry Potter series was originally published in Bloomsbury, and it has nothing to do with, sorry, can you go back? It has nothing to do with awards at all. So edification is where you provide some factual knowledge, but without any basis here in this particular case. And if you go to the next scenario, which is disclosure, here the person is saying, I did last year, I broke up with my girlfriend, and this is some personal information that cannot be verified by the given knowledge snippet. So this is much more frequent than edification. So do we really want our bots to do this? That's another question. So these are subjective, as I said. And if you look at models, is it just the data sets that are the problem, or there are problems with models as well? And if you look at GPT-2, and this is general purpose language model, right? And if you look at CTRL, this control generation, which is specifically designed to fix some of the hallucination issues, or Doha, which is another model. It has attention on the knowledge, it has attention to the history, and then generate response. So it's much more grounded models. Let's take a look at these models, what they do when you train on such data. Yes, so if you, you can just go ahead. Yeah, stop there. So if you see here, in the goal data, if you take hallucination, we had 66%, right? And if you take GPT-2 and if you train a model, the hallucination phenomena amplifies even further. And if you take CTRL or Doha, they are not as bad as GPT-2, but you still see in this particular case, the model Doha, it still amplifies to some extent. And if you take the model like CTRL, it actually decreases hallucinations, but at the cost of uncooperativeness. If you see it towards the extreme end, there will be grounded responses, but these are fully uncooperative. It's no use. Okay, so if you see these existing models, so these are extremely, the benchmarks are extremely hallucinated. The models also amplify hallucination. So it's, I think we have to be very aware when we actually use these models. So, oh, if you have a clicker, that would be great. Yeah, there is, I have a lot of animations. I did not realize this particular.
There are technical issues.
Perfect. Yeah, that's a relief. Okay, so how can we actually increase faithfulness or groundedness? So if you take, we created this benchmark called FaithDel, which is a data-centric solution for creating more groundedness. So what we did is we took visit of Wikipedia, where we know many responses are not hallucinated or hallucinated. And there are many responses that are also not hallucinated. So we did not want to throw away visit of Wikipedia. We want to build on top of visit of Wikipedia. And in this particular case, if the visitor of Wikipedia visit says that they broke up with the girlfriend, so we decided, hey, we want to stick to the presented knowledge. And we wanted to take a persona that is much more limited than what a person is doing here. So the persona that we asked our Faith Dial visit to be is a bot. And the bot says, I'm a mission, I cannot break up, or I don't feel pain. But I know that broken heart is intense emotionally. So this is, right. Yeah, so almost all responses in our data set are more faithful to the presented knowledge. And if you look at the statistics, so it has, because it's built on visit of Wikipedia, we were able to create a very large data set, which has 50,000 terms and 5.5 conversations. The good news is that you can now actually train a classifier that can tell you whether a response is grounded or whether it's not grounded, because we have visit of Wikipedia as well as our annotations. So if you take a look at this, so the design principles are that the seeker can talk about anything they want. We did not want to restrict the seeker, but the wizard, we wanted to restrict the wizard a lot. By that, we mean that a wizard should be a bot, and they should stick to the information that is presented, and they provide the information conversation, and also they should acknowledge the ignorance when they don't know the answer, which is not the case with visit of Wikipedia. There's no ignorance in visit of Wikipedia. It's as if they know everything. And if you compare these two data sets, so FaithDel, you see that almost it has no hallucinations. Most of the phenomena is entailment, and it has other dialogue acts as well, corresponding inside the entailment. Whereas visit of Wikipedia, 66% is all hallucination. And as I said, this, you can actually build a hallucination critic, and this is based out of both visit of Wikipedia data, because for every instance, we annotated another instance that is more faithful. So we can actually train a classifier that can tell you whether it is which one is entailed or which is hallucinated. And we call this faith critic. And this faith critic, we found that it can, if you take existing grounded benchmarks like begin, this is just a test set which can tell you whether something is grounded or not. On this, if we see that the faith critic that's trained on our data set, it generalizes very well in zero-shot setting. And the same with also MNLI, which was not the task that we were doing, right? It's mostly focused on dialogue, but still it generalizes to MNLI in this particular case. Okay, so if you take the modeling, what happens when you train on FaithDial? So what we found is that models behave much less hallucinated. So if you see, we see 42% drop in hallucination, as well as there are other faithfulness metrics like Q2 based on question answering, and we see increase in faithfulness of responses as well. And even in terms of human evaluation, we see that a model trained on FaithDial is much more cooperative, abstractive, engagingness. So the conversations are very natural, even though the persona here is a bot. Okay, and we also did this unanswerable questions. So here somebody is asking, I design video games. Do you play any video games? And this is the model T5 that's trained on us. Says, given the fact that I'm a bot, I don't play video games. However, I do know that applying so on, so on. And if you see the T5 wizard, a wizard of Wikipedia, I have always been, I wanted to be an artist. I think it's a fun hobby, so on, so on. Yeah, so this is the success rate. We see even for unanswerable questions, we can answer them with grace. The data set also transfers very well to out of domain, like topical chart. So you train on FaithDial, you can directly apply to topical chart as well. This is one way of improving groundedness, but what are other ways? So the other way could also be providing explanations for answers. So this is a paper that we presented at this conference. So if you take a deployed model, so if in this particular case, how should an OB-GYN handle a shortage of respirators, and the model produces an answer, and the because we are interacting with these systems, one can go and provide feedback whether that answer is good or bad, right? So this person says, hey, this is a bad answer. This is bad answer because it has nothing to do with respiratory shortages and so on. So they provide some reason. And now the question is, can we make use of such kind of data to improve the groundedness of the models that we deploy? And the answer is yes, you can actually do that. So the way we do this is you deploy your original system and collect feedback. Now you train a feedback generator that can take each answer, generate a response, generate an explanation why some answer is correct or incorrect. And you can use that to re-rank your answers. And if you do this, we observe that like if you take a model like BART, if it performs at 67, after generating feedback and re-ranking, we see that it goes up to 70. So this is almost for free, right? Because it's much easier to collect feedback data for deployed models. And also humans find these explanations very useful. So let me give you this question. Do we know how long the virus can survive without a host? And I did not even provide you the answer. I'm just providing you the explanation. This answer is excellent because it gives set time the virus can survive outside the human body. This answer is irrelevant because it is talking about spread of virus through food. Suddenly, these explanations make humans to pay more attention to what is being presented. And because of that, we observe this feedback improves the accuracy of selecting the correct answer by a human, as well as the agreement across humans. So both ways. Yeah, so in summary, I think this to increase faithfulness, we have to look into our data sets and reduce hallucinations. So FaithDial is one of those, and also we can make use of explanations to improve the groundedness. And for the final part here, we are, so until now we have seen that we have already given you a retrieved document, and we are testing whether the generated response is grounded on the retrieved document. But how hard is the retrieval itself, conversational retrieval itself? And it turns out it's very hard. And in order to solve this problem, so we have this much more constrained challenge where we can focus on the conversational retrieval. This is also presented in this conference, paper accepted at Tackle 2022. And the main thing is that so in conversations, people switch between topics, and that makes retrieval very hard. So if you see the chart here, someone is talking about topic 1 for the first 4 or 5 turns, and then they switch to some other topic topic. It's not a completely different topic. They drift away to a different topic naturally. And so on. Like you see that there's topic transition. So in reality, there are around 4 or 5 topic transitions per conversation. And so here we created this a constraint setting. So the constraint setting is that it's a question answering setup where the seeker always asks a question and the wizard always provides a answer to the response. So whereas in the faith DL, it's much more natural. You can talk about anything you want. It doesn't have to be question and answers. But this is important to solve before we solve the other problem because the setting is more restricted. It's easy to evaluate because of that. Yeah, so I would also encourage you to check out this very large data set. If you're working on conversational search, the next talk is also going to be on that. So I will not present detailed models, but we will look into this. So what does this tapioca data set has? So as I said, it has questions, and when was Byzantine Empire born? What was it originally called? And you have the wizard is providing you a response. And the wizard also has to go and find the relevant document. And here they found out it's the answer is in the Byzantine Empire. And they even highlight where they took the answer from and we generated the response. We do not provide any reference from it. It's a natural conversation that is happening between the seeker and the wizard. And this has free form answers, so it's not extractive, it's still abstractive, but easier to evaluate because the answers are much concrete compared to FaithTel or anything. And the main contribution is we wanted to explore this topic switching aspect between multiple topics. So if you see here, the first question was about the Byzantine Empire, right? And the next question was who conquered what battle marks country. Let's see this thing here. So the next question is about the Sultan Mehmed, and Q4 we suddenly switched to that person entirely. Did he conquer other territories as well? Yeah, like again, there's another topic which where is the first area located in present day terms? Now you're talking about the city Anatolia. Yeah. So the question that we were exploring is how do you represent conversations for conversational retrieval? So the question could be you can take the lost turn and provide it to the model and see how the retrieval performance is, or you could take the all history and just concatenate everything together and see what the performance is. Or one might say, hey, why don't I rewrite this thing into one single question and then perform the retrieval? So among these 3 options, we found out that the all history option where we combine everything works very well with the dense retrievers, whereas with the sparse retrievals like BM25, they get confused when you combine all things together because there are much more number of words, and now you retrieve some random document because it appeared in turn 1. And if you see the results, actual results, so BM25 is really bad. This is not the case in single turn question answering. BM25 and dense retrievals, they are competing with each other in single turn question answering, whereas in this conversational retrieval, it's much far, and the dense retrievals are the only way I think to go ahead, or you have to combine that with question rewrites. And if you see question rewrites, we tried the question rewrites as well in the dense setting, and we don't. There's a big gap between combining everything as and just taking the question rewrite. That's mainly because, as I said, it has multiple topics in it, and it's not easy even to rewrite a question when you have multiple topics. Okay, so you can also check out this particular work if you're focusing on conversational retrieval in a constraint setting. And we believe that this could be the first stepping stone before we solve data sets like FaithDial or something else, where you also try to do end-to-end retrieval as well as generate a response. Okay, yeah. So in summary, I think to improve grounding, first of all, we should be aware that existing data sets, they are not as grounded as we want. And to increase the groundedness, one may have to go and correct these data sets or rely on explanations. And also, I think as a community, we should focus more on the conversational retrieval setting rather than single turn retrieval settings. yeah, these are all my wonderful collaborators whose work I've been presenting today. And thank you for your patience.